Quadratic expressions are written in the form ax squared plus bx plus c. Even though we don't see the a, b, and c in the quadratic, those letters help us identify the number connected to each of our terms. So when we talk about a, we mean the number connected to the x squared. When we talk about b, we mean the number connected to the x. And when we talk about c, we mean the number at the end. Let's factor the quadratic 3x squared minus 17x plus 10. What's our a, b, and c here? The a is 3, the b is negative 17, and the c is 10. When you factor a quadratic, the first step is to find two numbers that multiply to equal ac. In this problem, ac would be 3 times 10, which is 30. So we need two numbers that multiply to equal 30. These same two numbers also have to add to equal b, which is negative 17. Let's start by making a list of numbers that multiply to equal 30, and then from that list, we'll find out which pair of numbers can also add to give us negative 17. Let's see. Negative 1 times negative 30 is positive 30. Negative 2 times negative 15 is positive 30. Oh hey, we can stop there because negative 2 plus negative 15 is negative 17. So we found our numbers. The numbers are negative 2 and negative 15. Okay, here's what to do with those numbers. We rewrite our expression, and instead of using negative 17x as our middle term, we replace that with negative 2x and negative 15x. Next, we draw parentheses around the first two terms and the last two terms. Then, we factor out the greatest common factor from each group. The greatest common factor of 3x squared and negative 2x is x. So we write x on the outside of the parentheses, and then we write the remaining factors inside the parentheses. The remaining factors are 3x and negative 2, because x times 3x would equal 3x squared, and x times negative 2 would equal negative 2x. We do that same thing to the other group. We find the greatest common factor of negative 15x and 10. It's 5. Now, since my negative 15x is negative and the 10 is positive, I can choose to factor out a positive 5 or a negative 5. I'm going to try it with a positive 5, and if it doesn't work, then I'll try it with a negative 5. When I factor out a positive 5, the terms left over inside my parentheses are negative 3x and positive 2. Look at the terms inside the other parentheses. Do they match exactly? Not quite. They're almost the same, but the negatives are a little messed up. Let's factor out a negative 5 from this group instead of the positive 5, and we'll see how that changes things. When we factor out a negative 5, the terms left over inside the parentheses are positive 3x and negative 2. That's because negative 5 times 3x equals negative 15x, and negative 5 times negative 2 equals positive 10. And look what happened when we factored out the negative 5. See the terms inside the parentheses here and here? Now they match exactly. Because they match exactly, we can finish up factoring this problem by rewriting our expression like this. X minus 5 times 3x minus 2. Now, here's why that works. Before, we had x times 3x minus 2 minus 5 times 3x minus 2. Instead of 3x minus 2, think of it as a bag of apples. If I had x bags of apples, and then I lost 5 bags of apples, how many bags of apples would I have altogether? I would have x minus 5 bags of apples. So because the terms inside the parentheses were the exact same, just like our bags of apples, we were able to combine them together and rewrite our expression so it looks like this. X minus 5 times 3x minus 2. And that's our final answer. Great work factoring this quadratic. You can subscribe to my channel for more math videos.